Okay, in this video we are in the middle of talking about integrating powers of secants and tangents. We went over the two easy cases, and now we're ready for case 3, which is sort of the worst case. And that is when m is even, so the power on the tangent is an even number, and the power on the secant is an odd. So none of these are case 1 or case 2. So in these examples, one way to do it is to switch all of the tangents to secant. All right, so switch every single occurrence of tangent, switch that over to secant using the Pythagorean identity. You can do that pretty straightforwardly because tangent, right, is even. And so you have tan squared or some power of tan squared, and you can switch that over. And so then when you simplify that all out, what you're going to wind up with is an integral that's a bunch of powers of secants. And so we've already covered how to go over those. And so you would integrate those with the techniques that we discussed about integrating powers of secants. So both of these are fairly small powers. This was a pretty easy one for case 3. And so these are ones that you just need to memorize, right? The integral of secant cubed is 1/2 secant x tangent x plus 1/2 natural log absolute value of secant x plus tangent x. And the integral of secant, right, is natural log absolute value of secant plus tangent. And so you've got some like terms here. I have half of one of these, minus 1. Carry out that subtraction, and I'll get 1/2 secant x tangent x minus natural log absolute value secant x plus tangent x plus some constancy. Okay, so for case 3, and in the homework, I looked through the homework. I don't even think I see many of those, if any, of these case 3s, but what you want to do if you have a case 3, right, is to change all the tangents to secant right off the bat, and then integrate by powers of secants, and that's pretty much it. So I did want to talk about cosecants and cotangents. Some of those problems are in the homework. So if you have powers of cotangents and cosecants like this, then you're going to want to use this Pythagorean identity, the one between cotangent and cosecant. You can get this one by using sine squared plus cosine squared equals 1, and then dividing through each term by sine squared to get this identity. And basically the same techniques that we used in integrating powers of tangents and secants will work with powers of cotangents and cosecants. So all of those techniques that we used will work for cotangent and cosecant. The only real difference, right, is that with cotangent and cosecant you have those annoying minus signs in their derivatives, but basically everything else is the same as secant and tangent. And so that about wraps everything up for section 7.2.